So in this continuing capsule and carbocation rearrangements, we look at a new reaction and a new rearrangement. The new rearrangement is here in red here, 1,2 methide shift in this rectangular box, in blue 1,2 methide shift. Previously we have seen a 1,2 hydride shift which led us to product 2. Without the 1,2 hydride shift, the expected product is product 1. This is the unexpected product. Product 2 is unexpected product, and then you see an unexpected product, you propose a mechanism to explain why that forms and how that forms. So we've seen that in the previous video. So in this video, we're looking at a very similar compound. The difference being, instead of a hydrogen there in the previous video, here now we have a methyl group, hydrogen versus methyl group. That's the only difference. But because of the because it's a different compound, you get different products. But we'll see in a little bit more detail how this rearrangement occurs. So let's start drawing the mechanism like we did last time in the previous video. So now here's the reaction, product 3, product 4. The mechanism is similar because you have an alkene and an acid. So this is a good thing about organic chemistry. Once you learn one mechanism, you can apply it. So you do not need to memorize all the thousands of reactions. We try to understand the mechanism, how these reactions happen, and then you apply that. So the double bond electrons are picking up the hydrogen and the bond breaks. So that will be our step 1. So I'll write the mechanism here. Step 1, I'll rewrite it. Electron flow from the double bond to hydrogen. And we must be careful about how we show the electron flow. So that's why we need to practice this. Not just read it, you need to write this down, once or twice, so you actually get this arrows, the direction of the arrows correctly. So anyway, so step 1 of the mechanism gave us the familiar, the secondary carbocation intermediate. So this is an intermediate, it's not the final product. It's not the final product, so it's an intermediate which undergoes, another mechanistic step to give us the products. Product 3, let's start with product 3. So you got this carbocation intermediate, which in the next step, so we'll draw that again, the intermediate, have that intermediate, will pick up the Br minus to form product 3. So you get product 3 that way. So product 3 is explained, that's quite straightforward, but how do we get product 4? So see, looking at step 2, the bromide captured the carbocation, they reacted there. So the bromide appeared on carbon 2 because there's an initial carbocation is in carbon 2, 1, 2. But in the unexpected product, product 4, the bromine ended up on carbon 3. That means somehow the initially formed carbocation, which is a secondary carbocation, changed, rearranged to form a tertiary carbocation. Also you notice that this methyl group, carbon 3, has 3 methyl groups. Carbon 3 has 4, 5, and then if you want to call it 6, it has 3 methyl groups. And notice one of the methyl groups moved to this point there. So let's see how that happens. It happens very much in parallel to what we have seen with the hydride shift. Okay. So we have the initially formed carbocation, tertiary secondary carbocation, and looking at the product 4 is this. This is product 4. In order for bromine to react at this point, that point should be carbocation. So we are explaining how the secondary carbocation became this tertiary carbocation. So that involves, similar to like last time, one of these methyl groups. In the last example it was hydrogen, so we call it a 1,2 hydride shift, H minus. Here the CH3 group is migrating along with its 2 electrons, so we call it 1,2 methide shift. So that methyl group is picking up those 2 electrons and migrating to this carbon. So you got a rearrangement. You got this carbocation, which then reacts with bromide. The bromide comes and reacts there. So you get this product 4. So this is another rearrangement. So anytime a carbocation can somehow become more stabilized, it will, by undergoing some type of rearrangement. It could be 1,2 hydride shift, or it could be 1,2 methide shift, okay? Or in general. Now let's go with methide shift, and then we'll look at other examples as they combine. So we'll stop here. In the next one, we'll look at rings and carbocations. Stop here.